Bismillahirrahmanirrahim. Assalamu alaikum. I am Kashaful Khair from BS Chemistry Department and my ID is 018. Today I am going to present the topic of analytical chemistry, which is ultra micro electrode. So let's have a look at the content. In this presentation I am going to tell you the ultra micro electrode, then principle and the properties of ultra micro electrode, structure and working of ultra micro electrodes, advantages of ultra micro electrodes and the applications of ultra micro electrodes. So moving toward the first part, which is an electrode that has at least one dimension, which is also known as critical dimension, and it should be smaller than 25 picometer. For example, platinum electrodes with a radius of 5 picometer. Nowadays, electrode with critical dimension of 0.1 picometer have been made. So the most common ultra micro electrode is a disc shaped electrode, which is shown in the picture. In the picture, there is a commercially available carbon fiber ultra micro electrode and its diameter is 5 picometer. These electrodes meet on a micro scale on the order of 5 to 10 to 30 picometer. The electrode is smaller than the diffusion layer thickness. Diffusion layer is a region in the vicinity of an electrode where the concentrations are different from their value in the bulk solution. Due to the small size and the large diffusion layers of the ultra micro electrodes, they result in enhanced mass transport that is independent of flow, increased signal to noise ratio, and electrochemical measurements can be made in high resistance media such as non-aqueous solvent. Here I use the term signal to noise ratio. Basically, signal to noise ratio encompasses the level of a desired signal to the level of background noise. In simple, we can say that ratio of the signal power to the noise power is known as signal to noise ratio. And the non-aqueous solvent or the solvent, or we can say that solvent other than water. They are used in chemical research and industry for reactions that cannot occur in aqueous solution or require a special environment. Due to the small size and large diffusion layers of ultra micro electrodes, they have small overall current. Ultra micro electrodes are used in voltammetry. Voltammetry is a type of electroanalytical method which is used in analytical chemistry and in industrial process. Basically, it gives us information about an analyte, about how an analyte is obtained by measuring the current as a potential. Then there is a part 2, which is the principle of ultra micro electrode. Ultra micro electrodes are electrodes with characteristic dimension on the micrometer and submicrometer scale. Micrometer scales are relatively small scale and are detailed scale, while the submicrometer scales are smaller than micro scales. Then there are the properties of ultra micro electrodes. Ultra micro electrodes have faster double layer charging. They have reduced ohmic loss. Ohmic loss is the voltage drop across the cell during the passage of current due to internal resistance of the cell. High mass transport rates have allowed them to revolutionize thermodynamic, kinetic, and electroanalytical measurements. Next is the part 3, which is the structure and the working of ultra micro electrode. Firstly, we will see the construction of ultra micro electrode. Ultra micro electrode consists of connecting wire, a glass tube, epoxy. Basically, epoxy is an adhesive which is used in the fabrication of ultra micro electrode. Fabrication is the process of manufacturing or inventing something. Then we use carbon or platinum fiber. Carbon fiber about 5 to 10 picometer in diameter are used. Basically, they have high tensile strength, lower weight, high chemical resistance, high temperature resistance, and have low thermal expansion. So that's why they are used. Then there is also a conductive epoxy. Conductive epoxy is epoxy with metal particles that can conduct electricity like glue. And they are microdiscs. Microdisc is basically a ultra micro electrode. Then there are adhesive. Basically, adhesive consists of an epoxy resin which is also called as silicon, filled with any metal or conductive carbon particle. We see a sigmoid current voltage curve instead of peak shape curve. Let's move toward the working of ultra micro electrodes. Basically, ultra micro electrode, it is a disc shaped electrode as we can see in the picture. It is a disc-shaped electrode created by embedded a thin wire in glass. The glass is cut and polished to expose a cross-section of the wire. Carbon fiber micro electrodes are fabricated with conductive carbon fibers sealed in glass capillary with exposed strips, and they are used in voltammetry. So, the limiting current of ultramicroelectrode is given by this formula, where N is the number of electrons involved in the reaction, F is the Faraday's constant, and Faraday's constant represents magnitude of electrical charge per mole of electron, and its value is 96485.3321 coulombs per mole. Then there is D, which shows big D, which shows the diffusion coefficient of redox species, and it is a proportionality constant between the molar flux due to molecular diffusion and gradient in the concentration of species. Then there is the C, which is the concentration of dissolved redox species, and small d is the electrode diameter. By using the formula, we can evaluate the RG value. The RG value is a method to evaluate the quality of the ultramicro electrode. Whereas smaller RG value means there is less interference to the diffusion towards the conductive material, and this conductive material resulting in a better or more sensitive electrode. We can obtain RG values from the calculation of steady state current. Here are some pictures or some types of ultramicro electrode. They are in disc shape, they are in drop shape, band shape, wire shape, ring, and so on. Next, part 4 is the advantages of ultramicro electrodes. The negligible values of sensibility of ohmic drop and the enhanced mass transport rate by spherical diffusion are the main advantages of ultramicro electrodes. The use of ultramicro electrode basically requires little simple manipulation, and in general no need of oxygen removal or the addition of supporting electrolyte is needed. So, small current at ultramicro electrode enables electrochemical measurements in low conductive media like organic solvents, where voltage drop associated with high solution resistance make these experiments difficult for conventional electrode. Next is a small voltage drop. Small voltage drop at ultramicro electrode leads to a very small voltage distortion at the electrode solution interference, which allows using 2 electrode setup in volumetric experiment instead of conventional 3 electrode setup. The part 5 is the application of ultramicro electrodes. We see applications of ultramicro electrodes in electrochemistry and electroanalytical chemistry. Firstly, we will see the application of ultramicro electrodes in electrochemistry. In the field of electrochemistry, ultramicro electrodes have been applied in studies of the hydrogen evolution reaction and the electrocrystallization of the metals. The application in electroanalytical chemistry involve the determination of contaminants such as heavy metals and nitrates in natural water and food production. Thank you. That's all from my side.